Okay, for our um, 7C notes, for pre-AP, I want to just sort of go down here and look at the second page here. The first page should be a review from our 7A notes. Um, so I just want to go over one of these, writing the equation of a circle when we don't have the radius, and then the pre-AP challenge problem on the bottom sort of incorporates stuff that we did from our previous um, unit. All right, so we know the um, formula for the equation of a circle. We have x minus h squared plus y minus k squared equals r squared. All right, and we always fill in a number for h and k and r, and then we're done. Okay, so on these problems, we have our h and our k because they give us a center. Okay, oh shucks. All right, so our h is at -1 and our k is at 8. However, we do not know our radius. All right, and so in order to find the radius, we're going to have to do some calculations. So luckily, we could use our circle formula here, and we see that the circle passes through 9 and 3, so we can use 9 and 3 and plug those in for x and y here. So if we plug those in for x and y here, we can sort of run this formula right through and get r squared. And again, the formula just turned into the distance formula anyway, like we talked about in class. Okay, so we have 9 minus -1, which is really 9 plus 1 squared. And then we have 3 minus 8 squared equals r squared. Okay, and if we calculate all this out, 9 plus 1 is 10, 10 squared is 100. 3 minus 8 is 5 squared, which is 25. So our r squared is going to be 100 plus 25, which is just 125. Now we don't even need to find our r, because again, all we're trying to do is write the equation of a circle. So once we have our r squared, we're sort of good to go. Now we can go back into our original equation. So now we have x minus h, which is x minus -1, y minus k, which is really y minus 8, because that's a k value. And now we know our r squared, after subbing this whole thing in, is 125. So we just have to do the equation sort of in a roundabout way to find our r squared, plugging these numbers in for x and y, and then we get our r squared. We plug our r squared back into our original equation, like so, just like that. Okay. Now I want to look at the pre-AP challenge here together. So we'll go down here again. These two are just the same as what we just did. So the pre-AP challenge here is what we got to do is, reading this problem, we need to draw a circle around those 3 points A, B, and C. All right, and what we're going to do is find out where the center of that circle is. Okay, because that's what we're trying to find. We have to find a center that's equidistant from the three cities. All right, and we're going to use our GeoGebra app to do this. Okay, so if we go to GeoGebra, and you can follow along, pause as you need to. Trying to find how do I get my internet up here. Oh, sorry. All right, so we go to geogebra.org/geometry. And we'll hit our more button like we always have. One thing I want to do is we can actually put a graph up here. So we'll hit settings, we'll hit show axes to show our axes, show grid, minor and major grid lines. So now we have a graph up here like so. All right. So now what we're going to do is we're going to go to the calculator tab over here. We're going to hit inside here. And our first point on our graph was 2, 5. So all we're going to do is type in 2, 5 there, and it puts our point A right where it goes. The next point was at 3, -2, and then the last point was -5, -2. So we have parentheses 3, -2. Hit enter. Should put your point B right there. And the last point was -5, -2. Hit enter. That'll put our point C where that goes. Okay. Next, we'll go back to our tool, and we'll hit our polygon button, and we'll draw a triangle from C to A to B to C, just like that. And then after that, we will draw a circle up. Okay, so if we go down to more, I think it's down here somewhere. All right, we're going to hit circle through 3 points. So we're going to go circle through 3. We'll click on point C, point B, and point A, and that'll give us our circle through those 3 points. All right. Now, in order to find the center of that circle, we need to go back to what we did back, I believe it was in unit 4 or 5, where we did constructions with perpendicular bisectors, angle bisectors, and what have you. And if you recall, if we have a triangle with a circle that goes through the 3 vertices of the triangle, the center of that circle is formed by the perpendicular bisectors of the sides of the triangle. Okay, so what we're going to do now is to find the center of this circle. Again, a circle that goes around the vertices of the triangle. Whoops. We need to find the perpendicular bisectors of 3 lines. And remember, the perpendicular bisectors will meet in the center. Okay, so all we got to do is we'll go to construct perpendicular bisector, and we'll click on the 2 vertices from C to B. That'll be 1 perpendicular bisector. Again, we have it. Click on the vertex A to B, and finally click on the vertex from C to A. You can see all 3 of those perpendicular bisectors are going to meet right in the center of this circle. Okay, and we can see clearly that the center of the circle is going to be at -1, 1. Okay, so in order to find a center of a circle with 3 points, all we need to do is do the perpendicular bisectors of the 3 sides and find out, where the center is from where the 3 perpendicular bisectors intersect. So the perpendicular bisectors intersect right there at -1, 1. So now that we have our center, -1, 1, we can find the equation of our circle, okay, but we do need to find also the radius, and so we're going to need to sort of do what we did up here to find the radius, okay? So that'll be that. Again, go back in the video, pause it, slow it down if you need, to see how it's done again. Hopefully it was explained pretty clearly, and so work on getting this note sheet finished. Thank you.